So we're here in Ghanzi, to be specific, at Takadu Game Farm. It's a private game farm here in the Ghanzi farm block, which is an area where people mainly live from cattle farming or the farming of wild species, game farming. And there is a big problem in the Kalahari, and it is that the Kalahari does not look as it used to look 100 years ago. So we now have this phenomena that is called shrub encroachment, and it takes place all over the Kalahari. We don't really know why that actually is the case. So scientists are still trying to figure this out. Some say it's because of increased CO2 levels in the atmosphere, so shrubs photosynthesize more. Other people say that it's due to management practices, which changes the competition between shrubs and grasses by the end of the day. But one thing is obvious: if you are a rancher and you're trying to raise animals that graze and shrubs take over, you have got less space for these animals to graze. So if you have more shrubs, it lowers the productivity of your farm. There are a couple of management tools to fight this problem, and one very effective tool is actually fire. And this is what we're trying to achieve here.
A fire regime is comprised of several different factors, including the extent of the fire, which means how big of an area is actually being burned, the season of the fire. Usually we see a bigger impact in dry season fires than we do in wet season fires. Another factor is fire severity, which describes how much damage the fire is doing to the trees or the grasses or the vegetation in that area. Lastly, we have fire intensity, which is measures the amount of energy that's released in the fire.
So here in the Kalahari, not a lot of people have done active fire research. It's not as actively done as it is in other parts of the world, such as Texas or California, where fires play a very, very important role. However, fires do play a very important role in the savanna ecosystem, but due to lower density of researchers, less money, etc., there's not a lot known what the impact of fire in this area is. And where we want to go to, let's say in a couple of years, 5 to 6 years, is to come up with recommendations in order to sustainably manage your ranch. Over the past couple of days, we have measured exactly 12 plots. 3 of them are control plots, and 9 plots will be burned tomorrow. We are measuring structure and we are measuring cover. So we are measuring all sorts of structural parameters of the tree, height, crown dimensions in multiple directions. Where does the canopy start at the bottom? Where is the majority of the canopy? Where is the top of the canopy? So, but now we have the situation on the ground before the burn. So now just imagine the fire runs through, and this fire will have a destructive effect. A destructive effect on the grasses, and if the grass cover is high enough, and depending on the height of the shrub, it will have an effect on the shrub or the tree species. But as usual, it's not that easy, because the damage is a function of the fuel load and how the fuel load is distributed. So now just imagine that fire is predominantly fueled by the grasses on the ground. And in our area where we are conducting the burn, which is approximately 500 times 300 meters, so just a small area, but the grass cover differs, the height of the grasses differs, etc. So, and if I have more fuel, I will most likely reach a higher temperature. That's why we have set up a couple of stations, 7 in total, that are able to measure temperature at different heights. Because if you have a lot of fuel on the bottom, this means most likely your temperature will be higher. And as you move up through just the grass cover, your temperature will most likely decrease. So we do have 2 different types of temperature measurement stations. The first type is a more accurate device, and it measures the temperature at 5 different heights. It's a K-type thermocouple. It's a type of thermocouple that takes up over 1000 degrees Celsius, and it has a data logger. But the problem is its maximum temperature is 40 degrees Celsius. So even in wintertime here in Africa, when night temperatures drop easily below freezing, but the day temperatures, if you expose that device to the sun, it already reaches 40 degrees. We haven't even put that thing into the fire yet. So that's why we built a little box around it. And the idea behind is to take this box, fill the box with sand. The box has a little hole on one end where we stick the thermocouple wire out that measures the temperature. We cover it in sand, we add water to it, we close the box. This gives us the temperature. Now at the end of each box is a little hose clamp with container where we put a known amount of water in. So as that fire sweeps over that station, it will release energy, and that energy will evaporate water. So just from the missing water, we will be able to calculate the amount of energy that has been released at this particular spot of the station, at this particular height. The second type of station is a type of a chalk. It's used in welding. And this little piece of chalk, think of it like wax, it melts at a certain temperature. So now we had to slice it up into pieces and pack that, in fact, into beer bottle caps. And we string these beer bottle caps with these pieces of wax-like stuff in it on a piece of wire which is attached to a pole, and the whole thing ends up looking like a Christmas tree. So our test area for our burnt has got fire breaks all around it. Fire breaks is nothing else but a cleared strip of vegetation that is approximately 7 meters wide. So we hope that the fire will not jump these fire breaks. So let's just hope all goes well, and let's hope that Hansi is still standing by the day after tomorrow.
We started burning at 8:30 in the north, which was a backfire going against the wind. This was in order to create an additional fire break as we set the fire from the south around 8:45, which moved rather quickly to the north. There were some wind gusts reaching up to 4 meters per second, but at another corner we also started burning additional fire breaks. This was in the western side of the plot. And we had several teams at each corner with fire beaters and rakes in order to manage possible fire jumps, which luckily didn't happen. So what actually happened was that the fire moved from south to north. In the very center of the area that we burned, you could see a severe damage and pretty high flames. And we're lucky to be able to control the fire throughout the 1.5 hours.
Now 1 day later, so the burn is done, obviously. Caused a little bit of damage, I guess. So I guess it's about 70% of the total area burned. So that's 70% of about 15 football fields. So we burned about 15 hectares. And we can actually see clearly that most of the heat, most of the damage is of course done on the ground level where most of the biomass is. If we look at this tree, whatever that was, I guess it was an acacia flecky, and it's completely dead. The question, no more leaves, nothing, no more hooks, everything burned off. And the question is, does it have enough energy in the roots to recover? So we will see that, unfortunately, only next year. So, but we can also see in the back here, this used to be a Combretum herreriense, so bush willow. Not a lot left, it's basically dead. So we'll see if this one recovers, most likely not that one. And then it's about these small trees over here, the camel thorn acacia. You can clearly see leaves are burned dry, nothing green, it's dried out. But I guess it has a fairly good chance of survival in this case. A little bit of scorching on the stem, but they are relatively fire resistant, so this one will most likely come back. Unlike this tree in the back, it's pretty dead. So, and yeah, not a lot of grass left. We see a couple of patches, depending on how much grass biomass there was, that are not burned or not that much burned. So, but overall, I'm pretty happy. It's a success so far. So all our temperature measurements actually worked. So our 2 high accuracy electronic stations, nothing got broken, the data logger survived, etc. So it was a good setup. And then our completely improvised measurement station using the temper sticks. Surprisingly, they worked as well. So we got some pretty good results. So far we still have to look at the data a little bit more in detail, but what we know so far is that we reached maximum temperatures of about 450 degrees at ground level or at around 50 centimeters. So there's quite a gradient at the top height of about 2 meters. There wasn't a lot of change in terms of temperature. Most of the damage happened anywhere between 0 and 1 meter. So that was expected. What I didn't expect was the actual speed of the fire. It was way faster than I thought it would be, but I guess at maximum wind speeds of about 4 meters per second, this can happen. So since it's all done, we now have to do all the remeasurements for our plots. Then what's coming in the near future is that we will fence 3 of the plots in order to keep the wildlife out. So we will see the differences between regrowth under grazing and browsing pressure and regrowth under no pressure at all. Then hopefully next year we will burn 3 of the plots from here now every single year, and then 3 other plots every 5 years, and the other 3 plots we will not touch at all, see what happens, and plus we have our 3 controls. So yeah, that's the perfect setup, I would say, for a scientific long-term experiment. We're hoping to be busy with that for the next 5 to 10 years, I guess. And if you are an undergraduate student and you want to do some work on this, you're more than welcome.